Good morning, students. Um, Now see the torque equation of synchronous motor. Torque equation of synchronous motor. So this is the special torque equation. Why I'm telling this is a special torque equation means this torque equation is found from the phasor diagram of the synchronous motor. Okay. So now first we see the phasor diagram or vector diagram. Right? Normally motor, whatever with the motor, it have a resistance. So just you write the draw the resistance. Then it have a inductance. Okay. Now the input is V, right? The current through this loop is I. Primary armature, no? So IA, armature current. Then the resistance is R, A, armature resistance. The inductance normally it is X. Series, no? XS. Now the apply voltage V is flow through, drop across here, then drop across here, then finally it is called as a voltage source EB. That is V is not is equal to EB. V is the applied voltage, then the voltage is dropped here and dropped here. Finally, it's EB. Okay. Now you see the secondary side. Secondary side also have a inductance and a resistance. Yes. Now I draw the same diagram. Resistance, inductance, EB, then your applied voltage V. Then the secondary side resistance. Then this I change the inductance position. Are you clear? Now it's look like a transformer. That is primary, secondary. But it is a motor. So stator, rotor. What is the difference between transformer and motor is both are same, but transformer is a stationary motor or motor is called as rotating transformer. Are you clear? Transformer secondary is stationary, but in motor secondary is called as rotor. Rotor will be rotating, no? That's why it's called as rotating transformer, right? Now the current here is IA. The current here is resistance is RA. Then inductance is XS. Okay. Now we draw the phasor diagram. First, E. Take this as E. That is the applied voltage. Then it is the inductors, no? Resistance is negligible. So motor have a lot of inductance, right? So here I have a current. The current is lagging. It is IA. Extend the voltage. Because suppose consider why I'm extending the voltage means it's a magnitude. Consider or to a house we have voltage is 230 volt, current will be 5 ampere. That is a magnitude is. So here just I'm consider the magnitude of the current is less. The voltage is high. That's why I put a short distance line. After that, what is EB? EB is the resultant of E and I. EB. Okay. So EB is the resultant of voltage and current. Now, current is flow through the resistance. Current is flow through the resistance. So the angle is in phase with the IA. Normally, current is flow through in resistance circuit. It is in phase with the input current. Current is flow through the inductance circuits means that current is 90-degree angle difference between the current flow through the resistance. Suppose here the current through the resistance is 0. That is current is there but the angular difference is 0. That is in phase. But here current is flowing no, that is out of phase. That is current is flow through the resistance, voltage and current are in phase. But current is flow through the inductance, both are out of phase. That is the difference between resistance and inductance. Resistance in phase, there is no phase. Here 90-degree phase. Now the current flow through the resistance is in phase with the IA. Okay, that's why the phase. This is in phase with the IA. That's why this current will be parallel to the IA. This and this are parallel. Are you clear? Okay. Then the here it is the IA RA. This is IA RA is parallel to this, right? Now the current flow through this is 90-degree phase shift. That's why this is the 90-degree phase shift. It is IA XS. Very clear? Then it is origin 0 EB. Then what is this? Hypotenuse or diagonal. Diagonal is IA into ZS. What is Z? You know, Z is equal to root of resistance square plus XL minus XC the whole square. Okay, here there is no XC. So only Z is equal to root of R square plus XL square. Okay, so here ZS. ZS is nothing but root of R plus XL. XS is the synchronous motor, no? That's why we are telling this XS is the synchronous reactance. Have you clear? This and this are parallel. Then this and that is IARA and IAXS are 90-degree angle difference. Okay. Then this is the diagonal. Now listen. Normally, to consider the synchronous reactance, this value will be negligible. Okay. So in the next diagram, this IARA, no, I cut this position, cut this, because this is negligible. Then what happened? Then IAXS is merged with the IAZS. This is not ZS because R is negligible, no? So it is not ZS. It is nothing but IA into XS. Are you clear? This value is high, so I cut this resistance value. Now I cut this, no, so there is nothing is there here. That's why this is shifted into this position. Are you clear? Okay, we'll see. Now what is this? Voltage, then it is the current IA, then this is your angle EB. Now there is no resistance, no, only it have a reactance. That's why it is your reactance value IA XS. Now just I draw the line. This line give a two right angle triangle for me. So the voltage and current is totally is I pi. Then what is this? This angle is alpha. Okay, right. Then same thing. Just I'm extending this line and I draw a line here. Consider this is your A and this is your B. This is always B. AB, right? So this is your pi. Then what is this? 90 minus pi. Are you clear? Okay. Now from this I form my equation. What's the equation? So listen here. I find out AB. What is AB? AB is equal to, okay, anyway, first we find out the sine alpha, right? We find out sine alpha. Sine alpha, where is alpha here? Okay. What is sine? Sine is nothing but opposite side by hypotenuse, right? So what is the opposite side? Opposite side, this is your opposite side. This is your opposite side, right? This and this are equal, no? So opposite side is AB by hypotenuse. What is hypotenuse? It is EB. Very clear. Actually, this is the opposite side. This is the hypotenuse. This is equal to AB. Then this is your hypotenuse. What is that? EB. So A. Okay. So AB is equal to what happened? EB sine alpha. I got this equation. Are you clear? Right. Now we find out the cos alpha. So I'll put here. Next one is we find out the cos alpha. Sorry, cos pi. What is cos pi? Cos pi is nothing but adjacent side by hypotenuse, right? So cos pi. Now see the diagram. The cos pi. What is the cos pi? So this is your cos pi. Cos pi is equal to adjacent side. What is adjacent side? AB. What is hypotenuse? IA into XS. Are you clear? This is your right angle triangle. So cos pi is equal to AB up adjacent side divided by hypotenuse. So divided by IA XS. Now see here. So what is adjacent side? Adjacent side is AB divided by what is hypotenuse? IA XS equal to cos pi equal to cos pi. Now what I do means in here the first term AB is equal to EB sin alpha. The second term AB is equal to IA XS into cos pi. Are you clear? AB is equal to EB into sin alpha. Then AB is equal to IA XS into cos pi. Now left hand sides are equal. So EB sin alpha is equal to IA XS cos pi. Okay, in this we studied cos pi is the true power, it is the waste power. Sine power is waste power, normally we are telling. Anyway, so here I am find out this IA into cos pi. What happened? Because I want cos pi, no? At the same time, you want a current. So IA cos pi is equal to or cos pi கூட எடுத்துக்கலாம். Okay, IA cos pi is equal to what happened? EB sin alpha divided by cos pi or IA cos pi equal to IA cos pi is equal to EB sin alpha. Here is XS. Here also XS is missing now. It is your XS. Now you find out IA cos pi. This is our interested answer. So IA cos pi is equal to EB sin alpha XS. Right? Now we'll see here. What's that? IA cos pi equal to EB sin alpha XS. Now you know what is power? Power is equal to V into I. Here V into what is I? IA cos alpha. Sorry, IA cos pi. Right? Now, what is power? Power is equal to V into IA cos pi. Right? Now, listen. What is IA cos pi? V into EB. Early we find out, no? IA cos pi is equal to V into EB sin alpha divided by XS. Okay, now listen. So this is for single phase. Three phase means what happen? Just you multiply with the 3, that's all. Yeah, how you multiply? Just 3 into V into EB sin alpha divided by XS. So this is for 3 phase power. Okay, single phase means just it is the 3 into VEB sin alpha. Here it is the 3 phase power. 3 into VEB sin alpha by XS. Are you clear? Next, now you got a power for three phase, right? Next one, actually it is called as power developed. Three phase power developed, right? Now next one, you know torque, right? Torque. What is torque? Torque is equal to force into distance, right? That is torque. Then power developed, PD is equal to torque into acceleration omega. Okay, right. Power developed is equal to this. Now, what is torque? We find out torque, no? So torque is equal to power developed divided by acceleration omega. What is the power developed? This is your power developed. Now what I do means just torque is equal to, what is the power developed? 3 VEB sin alpha. So 3 VEB sin alpha. Each and every time you forgot x's. Okay, so divided by x's. It is x's. This is your power developed by omega. Okay. Now omega. What is omega? Omega is equal to 2 pi f, right? Then f is equal to 1 by t. Okay. So what is t? T is equal to 60 by n revolution. So I'm substituting this value. Now your omega becomes, what happened? Omega is equal to 2 pi n by 60. This is your omega value. Are you clear? Now you substitute this omega value here. You get a torque of single phase, synchronous motor. You get a torque of synchronous motor. Okay. Now see here, a torque equation of synchronous motor. This is your voltage. This is your resistance. This is your inductance. So totally called as ZS. It's your EB. Then secondary side it have a winding. Now this IA current flow through this RA. There is no phase difference between voltage and current. Suppose this produce a voltage difference of 90 degree. Okay, right. That's why first I draw a voltage, then I draw a current, then this is your, what is this? Equivalent. It is your EB. Now the IARA is parallel with the IA because there is no phase difference, no? So this is your IARA. But IAXS is 90 degree phase difference. Then finally this is your IAXS. But we are neglecting this resistance. So I'm shifting this IA XS to IA ZS position. There is no ZS because I'm neglecting the RS. No, there is no ZS. So this is shifting to this position. Are you clear? Then what I do means in this is shifted into this position. Now you got a one triangle. Then I draw a line in the center. The one triangle is split into two triangles. Actually, this is pi, then this is alpha. Same thing, that is shifted. So what happened? It is alpha. Then I'm extending this line. This is AB. So it is pi. It is 90 minus pi. Now what I do? If everything will be over. Okay. Now I find out the sine alpha. What is sine alpha? Opposite side by adjacent side. What is opposite side? AB is your opposite side. This is your opposite side. So you can just AB. Then your hypotenuse is EB. Okay, sine is nothing but opposite by hypotenuse, right? So from this you find out the sine alpha. Then what happened? Next you find out the cos pi. How you find cos pi is equal to adjacent side by hypotenuse. What is adjacent side? Adjacent side is AB. Hypotenuse is IAXS. So in this I find out the sine alpha value as well as cos pi value. Now AB is equal to EB, sin alpha equal to AB by EB, EB sin alpha cos pi. Now what happened? In the left hand side, ABs are equal. So right hand side, I am assuming EB sin alpha is equal to IA excess cos alpha. Then finally, you find IA cos pi is equal to, you get this answer. So this is your IA cos pi. But power is equal to, let's see. Okay, see here. What is power? Power is equal to V into I into cos pi. So, what happened? Power is equal to V, EB. This is the value of IA cos pi. Now, I am substituting. This is for three phase. I want single phase. What I do? Just I multiply. Okay. Now, this is called as your power developed. Same thing. 3 put develop பண்ணீங்களா, that is called as power developed. Now your torque equation is equal to power developed by acceleration. So what is torque? Torque power developed. This is your power developed divided by acceleration omega. What is omega? Omega equal to 2 pi n by 60. And the derivation I'll tell how we will get this 2 pi n by 60. Now substitute this. You get 0.9 per torque is equal to 9.55 power developed divided by n. Newton meter is the unit. Okay, so students, this video I'm making for you, so especially for first year ECE, right? So please study this. Then you have any doubt, please give your comment. Otherwise, enter your register number for verification. This is Karthikeyan, Velammal Institute of Technology, Assistant Professor of ECE Department. Anyway, thanks for watching. Thanks for listening. Thank you.